guys. My name is EJ from EJ. My name is EJ from EJ Tutorials. Today I'm taking guys nuclear physics. I know a lot of you might be familiar with nuclear physics. In fact, some of you might be scared of nuclear physics. Like, what is nuclear physics? Like, this thing is tough. Like, it's a tough aspect of physics. But I'll have you know that today that nuclear physics is not really difficult. So we'll give you a full breakdown here with this tutorial now. We'll explain all the concepts of nuclear physics. We will do with questions related to nuclear physics, binding energy, what have you, in this video. So let us start. Let us commence. What is nuclear physics? So nuclear physics is just the branch of physics that deals with the study of the constituents and interactions of atomic nuclei. So when we are talking about this atomic nuclei now, is our nucleus. Do we know what it means? Okay, what is a nucleus? The nucleus is made up of two particles, which are protons and neutrons in our nucleus. So the protons, they carry a positive charge. The protons carry a positive charge, and the neutron has no charge. It is electrically neutral, zero. The charge is zero. So now, together the protons and the neutrons, in nuclear physics we call it nucleons. Protons and neutrons, they are called nucleons. Note that. It's something you can just learn and note. Now, we'll move on to the atomic number now. So what is the atomic number? The atomic number is the number of protons. Then next, we'll go to the neutron number, which is just the number of neutrons. Usually it is represented as, for the atomic number, represented as Z. For the neutron number, represented by N. So then we now have the mass number. The mass number is just the total number of the nucleons. Now remember that we already said the nucleons is the proton and the neutrons. So when we add our proton plus neutron, we have our mass number. So total number of nucleons is just the proton plus neutron. So mass number A, usually denoted by A, is basically just Z plus N. Our Z is atomic number of protons, plus N, which is our neutron number. So A is Z plus N. So let's look at this example now. We have carbon 12. So this up here is our A, which is the mass number. This down here is our Z. So if peradventure they give you a question, they give you an element, they give you in this format, it's represented like this now. So how do you now say find the neutron number or so. Since you already have A as your A, the top will be your A, and you have the down here as your Z. If you want to get the number of neutrons, all you need to do is you subtract the A from the Z and you get your number of neutrons. In this case now, if you subtract 12 from 6, we have 12 minus 6, that is 6. So 6 now is the number of neutrons. So this is carbon 12 with 6 protons and 6 neutrons. So now we also need to note this in isotopes. What are isotopes? Isotopes are atoms of the same element with the same atomic number. Remember that atomic number is number of protons. So they have the same number of protons but different number of neutrons. Same number of protons, different number of neutrons. That is our isotopes. So I'll clean this off so we go on to it. So now guys, we'll be looking at examples on calculating the number of neutrons. Now look at this example now. We have three elements. We have sodium, we have uranium, we have hydrogen. Now we have to calculate the number of neutrons in one, the sodium 23, uranium 238, and hydrogen. So now let's solve this guys. Now solution. So for the first one now, we have the mass number as 23, we have our atomic number as 11. So our formula is atomic number equals, now in this case now, our atomic number is 23. So atomic number is 23. Number of protons is 11. So we are looking for a number of neutrons. So if we bring 11 to the other side, we have 23 minus 11 equals N. So our number of neutrons is 23 minus 11. So now our number of neutrons is 23 minus 11, which is 12. Now looking at the second question, still using the same formula, A equals Z plus N. So we have the mass number for uranium-238 as 238. We have the number of protons to be 92, and we are looking for a number of neutrons. So what is our N in this case now? Our N is 238 minus 92. So in the end is 146. So for the third one now, for hydrogen now, same formula, A equals Z plus N. So our mass number A is 1. Our number of protons is 1. We are looking for our number of neutrons. So now our N is 1 minus 1. So our number of neutrons A is 0. So this is the solution for the 3 questions. Now there are cases where you might have isotopes of different elements. We talked about the definition of isotopes earlier. We said they have the same number of atoms, like they have the same atomic number, but they have different mass number. So those are the isotopes. So there are cases where you will encounter isotopes of elements. So in those cases now, like for this uranium now, it might not be 238. In those cases now, the number of neutrons that you'll be getting for this same element uranium will be different. So you must make sure to note those cases where the number of neutrons for that particular element is different. So to be absolutely sure of your answer, you must make sure to get a number of neutrons, you subtract the mass number from the atomic number using this formula, and you surely get your answer for the number of neutrons. So that is a tricky part that might come up that I want you to be aware of. We're looking at strong nuclear force. So what is strong nuclear force? Now there is a force that exists in the nucleus of an atom. We are talking about the nucleus, we are talking about the protons and the neutrons. So now, the strong nuclear force is the powerful attractive force that acts between nucleons. It has a short range. So it also overpowers the electromagnetic repulsion and successfully binds the nucleus. So whenever you see something related to nuclear force, or you are curious, like what actually binds the nucleus in an atom together, it is the strong nuclear force. So that's what they call the strong nuclear force. It's the force that exists in the nucleus of an atom that binds the nucleons together.